Hey y'all, we are going to be factoring polynomials today. Okay, normally in class, I give you like a printout and then we fill it in. Let me show you. We fill it in like this. So what I did this year is I actually made it into a like a clickable thing, an interactive notes, I guess we can say. So basically what you're going to do is anything that has a purple box around it, you can click on. So if you want to learn more about synthetic division, you can click this and it'll show you the synthetic division example. And then if you click the home, you can go back to the main screen. So what we're going to do is we're going to explore this by doing examples. So you need this link because it's like the basics here, but we're going to do examples using this link. I don't know what to write down for this, but we want to basically we want to factor polynomials completely. We're basically going to do factoring this way until we can't factor anymore. That wasn't me, if you could hear that. Just saying. Basically until everything is a binomial, two terms, or a trinomial that can't be factored anymore, or like a monomial in front. So we're gonna show you all these things. I'm gonna show you all these things. I don't know what the we is all about, but we're gonna do this together. You ready? Okay, let's do our first example. Okay, we're gonna do x cubed plus 10x squared plus 24x. So first of all, I'm gonna check for greatest common factor. And what that is something that can multiply to get x cubed and 10x squared and 24x. Now the x cubed doesn't have any numbers in front of it, so I can't take out a whole number, but there is an x in here and in here and in here. So I'm actually going to show you what this looks like on here too. So for a greatest common factor, we're going to be undistributing it. So I'm going to take it out. So basically I'm going to undistribute the x, and to do that I'm going to subtract 1 from every power. So this is an x squared, and then this is a 10x, and this was a 24, so there's no more power here. Okay, and then I can factor this some more. So I have 3 terms. Clicked on the wrong box. It's probably a quadratic. Let's do an x puzzle. So here I'm going to do an x puzzle with this section of the problem. So I have 24 on top and 10 on bottom. This has not changed. And I'm so glad this was your favorite method because a lot of you said it on your midterm. Well, 24 is 4 times 6. If this was a negative 24, it'd probably be 2 and 12 to make 10, but it's positive 24, so we're going to do 4 and 6. So this x still just stays right in front. But this parenthesis set becomes x plus 4 and x plus 6. And that is all she wrote. I know that looks really easy. It's going to get harder, I promise. Don't worry about it. Okay, let's do another one. Let's try. I have my little notes here for all the ones I wanted to do. let's do 5x to the 6th minus 125y to the 4th. Nope. That should be an x. Hold on. Chill. It doesn't really matter which variable it is, they just have to be the same or else it doesn't work. Okay, we're going to do the same thing here. I'm going to take out a greatest common factor. Well, 5 and 125 can both be divided by 5, so I'm going to do that. And then the lowest x value, because there's an x in both these, is x to the 4th, so I can take an x to the 4th out of both. So when I do 5 divided by 5, I get 1. I'm not going to write it. And then I subtract 4 from the power, so this is x squared. And then 125 divided by 5 is 25. And there's no more x to the 4th. Okay, now here's where it gets kind of fun. This has 2 terms. But with 7 digits of cubes, I have to actually have cubes. And I don't have any cubes here. So this is actually probably a quadratic. Let's do an x puzzle. When I don't have a middle term, I would put 25 on top and I would put 0 on the bottom. So what times what makes 25 and has to get 0? Or negative 25, I should say. 5 times 5. If it's positive 5 and negative 5, that makes negative 25 and we're good. So my factors are 5x to the 4th, still it doesn't change. And then this becomes x plus 5 and x minus 5. So my second example is that you can't just always follow the flow chart, and I am so sorry about that. That's a special type of quadratic. Okay, let's do another one. We're going to skip that one. Hold on. Perfect. Let's do one that actually does do the sum and difference of cubes. Let's do x cubed minus 64. This has two terms and one of them is a squared. Probably a sum and difference of cubes. Now we have these really fun formulas where if it's something cubed plus something else cubed, it's going to be something plus something and then blah, 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 blah. This one's minus, so this is a difference of cubes. So this is something cubed minus something else cubed. Let's identify what a and b are. Well, something cubed makes x cubed, that has to be x. So a is just x. But b, what times what makes 64? Well, I kind of give you a little hint over here with my perfect cube box. 4 to the power of 3 is 64. So b is 4 because 4 times 4 times 4 makes 64. So now I can do my sum and difference of cubes formula. So I'm going to look at this difference of cubes over here. A, which is x, minus b, which is 4. X minus 4. And then a squared, x squared, plus x times 4. We're going to write 4x because we don't really want to write it the other way. Plus b squared. 4 squared is 16. Now, can I keep going at all on this quadratic right here? No. It's good to check, but I'm going to give you a hint. Whenever it's a sum and difference of cubes, this will never be factorable. I did an entire year once where I did the sum and difference of cubes formula wrong, where I put a 2 in the middle, and it was always factorable, and that got confusing because I messed up on that one. So I'm so sorry to that class that called me a liar a couple times. Let's do another one kind of similar to that. Let's do negative 16x to the 5th minus 250x squared. We're going to take out the greatest common factor just like always. We didn't in this case because this one didn't have a number and this one didn't have an x, so I couldn't take anything out. But here they both have numbers and they both have x's, so I probably can. 16 and 250, I know they both divide by 2 because they're even numbers. I don't think this one divides by 3 or that one. This one might, but that one doesn't. 4, 5, not 5 doesn't go in here. Okay, so I think it's just 2. So we're going to take out a negative 2 because I noticed that negatives are in both. And I'm going to take out an x squared because there's an x squared on the end here. All right, what am I left with? That's 8x to the 3rd plus 125 with no x on the end there. Okay, great. So let's do the same thing as before. I'm going to look at my sum and difference of cubes formula and see what I got. This is a sum of cubes. You can tell because it's x cubed and then nothing over here, but let's talk about this. 8 is on my list. 8 is 2 cubed. And 125 is on my list. That's 5 cubed. So my a value is going to be 2x, and my b value is going to be 5. So the negative 2x squared stays right there. And then I get 2x plus 5. And then I have a squared. If I do 2x times 2x, I'm going to get 4x squared. Minus 2x times 5 is 10x. Plus 5 squared is 25. Whew, I almost ran out of room there. Once again, I can't keep going on this one on the end. It's just not going to work when I do sum and difference of cubes, but you can try if you want. All right, let's do another one. Let's do, again, I have this whole list of ones that I wanted to try with you. We've done that. Let me see what else we need to do. Let's do a factor by grouping one. So we're going to do x cubed minus 2x squared minus 9x plus 18. Okay, this might be the one that I actually did in factor by grouping. No, I didn't. Okay, good. It looks familiar with the 9. So what I'm going to do is I'm going to try to factor out a greatest common factor. There's no number here to factor out, and there's no x here to factor out. So I can't factor by, or I can't do greatest common factor. So for factor by grouping, what I'm going to do is I'm just going to cover up the end of this. And I'm going to do greatest common factor just on these two parts. So x cubed minus 2x squared, I can take out an x squared. So for this group right here, I can take out a 2x squared. Might be, oh, sorry, I can just take out an x squared. Did I say 2x squared earlier? And I'm left with an x minus a 2. And I do the same thing for the other half. Now, the tricky part here is that if there's a negative in front, I want to take it out because I want this to be the same. It's just a weird rule. But I can take out a 9 out of both of these, and I'm going to take it out as a negative 9. So what I'm going to have left is I'm going to have x minus 2. These are the same term. So I factored this by grouping and got x squared times x minus 2 minus 9 times x minus 2. What I'm going to do is I'm going to factor out this x minus 2. I'm going to take it out in front. So what I'm left with is this x squared right here and this minus 9 right there. There is no squared as a power here, just like I don't take out an x to the 4th or something when I take out the x squared. I'm just taking these two and I'm undistributing them from the math problem. I know, it's confusing. It's okay. All right, now this x squared minus 9 is a quadratic. If I do negative 9 and 0, that'll be 3 and negative 3. So this x minus 2, oops, no, I'm good. I thought I forgot the x squared. X minus 2, and then this is x plus 3 and x minus 3. Okay, let's do another one. Let's do one where I already know one of the terms. So let's factor x to the 4th minus 2x cubed plus x minus 2. And it's going to look like this. It's going to have a little dot, semicolon next to it, and it's going to say that x minus 2 is a factor. Okay, so x minus 2 is already a factor of this. So what we're going to do is we're going to do some synthetic division. We're going to put negative 2 chilling over here. Oh, positive 2. I almost messed up my own synthetic division. And then we're going to go 1, negative 2, 0, good catch, 1, negative 2. Arrow and a line. If you have not done the last homework, do it, or else this will not make any sense to you. Please do that. Multiply. 2 times 1 is 2. Add, that's 0. Multiply, that's 0. Add, that's 2. Multiply, that's 2. Add, that's 3. Something's wrong. Hold on. That didn't take me too long. 0 plus 0 is not 2. Sorry. Okay, 0. Multiply, that's 0. Add, that's 1. Multiply, that's 2. Add, that is 0. Now, when we have this kind of thing, I want this to divide nicely. So I want this to be 0. Great. If I don't have a 0, I don't have anything. That's not a factor. If I either did something wrong, which is what I knew I was doing wrong when I got to a 6 over here. So maybe make sure this is right or make sure you didn't miss anything. But this has to be 0 or else you can't keep going. Okay, so then one of my factors was x minus 2, like it said before. And then this is going to be an x cubed plus 0x squared plus 0x plus 1. That looks like a sum and difference of cubes, by golly. I have a cubed, and then is 1 something cubed? Yeah, 1 is 1 cubed. So then a is x, b is 1. So I have x minus 2 still. Then I have x squared. No, I have x plus 1. Man, I can do this. I forgot this first part, the a plus b. And then I have x squared minus x plus 1. Am I running out of room? I sure am. Hey, if you want to see more examples of any of these, literally any of them, ask me. I'll do it. Oh, I need to do the one that has a hidden x squared in it. Oh, well, we're going to make this work down here. Okay, so we're going to do, hold on. I wanted to simplify it first. So we're going to do x to the 8th plus 5x to the 4th plus 4. Okay, this is a super, super secret hidden quadratic. And I know, here's how I know. I know because this is double what this is. Okay, this is double what this is. So if I wanted to rewrite this as a quadratic, I could write this as x to the 4th squared plus 5x to the 4th plus 4. So this is something squared plus 5 times something plus 4. This is a quadratic. It's a crazy quadratic. It's actually a 3 trinomial, but it's a secret quadratic. We can factor it just like it is one. So 4 and 5, yep. 4 is 4 times 1. So normally what we would do is we would write x plus 4 and x plus 1. But this isn't your average ordinary quadratic. It's x to the 4th squared. So this is x to the 4th plus 4 and x to the 4th plus 1. I know. This one you can generally go further if one of these is negative. So if this was an x minus 1, I would keep going. That'd actually be a fun one because that would be a lot of things. But we're not going to do that today. I'm going to give you a hint actually as we go too. The power here, if I add up these powers, I should get the same number. So 4 plus 4 is 8. 1 plus 1 plus 2 is 4. 1 plus 1 plus 1 is 3. Sorry. This is what happens. 2 plus 1 plus 2 is 5. 1 plus 2 is 3. 4 plus 1 plus 1 is 6. And then 1 plus 1 plus 1 is 3. So that's kind of how you know you got, you didn't lose anything along the way, as you can add up those powers. Once again, for the fourth time, first of all, I'm so sorry this took so long because it shouldn't be this long of a note. I apologize to you. If you want me to do any of these more with like a page of them, or if something's confusing to you, or if you want more help, please email me. I will do it. I got you. These are confusing. And we're doing quite a few of them at once, but we're going to take 2 days on it. So, next time we're going to talk about solving it, but it's the same. So don't stress too much if it's confusing now, but let me know if it is so I can help you out, okay? All right. Have a great day.